Hello students, welcome to engineering assignments. In engineering assignments, now we are going to solve some examples on MLE. Now let us start with the question. The question is, a coin is tossed 100 times and lands head 62 times. What is maximum likelihood estimate for theta, the probability of head? So here what is done is tossing a coin. Tossing a coin is actually a binomial distribution. It's a discrete probability distribution which always has some Boolean values like yes or no, success or failure. And this binomial distribution here is Bernoulli's distribution. So probability mass function of Bernoulli's distribution is, we have NC of x, p raised to x into 1 minus p whole raised to n minus x. So here x successes occurs with probability p raised to x and n minus x failures occurs with the probability 1 minus p whole raised to n minus x. As our problem is asking to find the probability of head, so this portion or this part will be dealing with the probability of head and this part will be dealing with the probability of tail, because tail is taken as failure in this case. Okay. So students, whenever you get a question like this, the first thing you have to do is you have to find out the probability mass function of that particular situation. Okay, here we have got, it is a Bernoulli's distribution. Now with this equation we are going to find out maximum likelihood estimation for head. Okay. So according to the previous video, the first thing what we have to do is to find out the likelihood function. So likelihood function can be written as pi I is equal to some 1 to n f of xi given theta. Okay, so that will be written as n c of x p raised to x into 1 minus p whole raised to n minus x. Alright. Here in this problem it is already given a coin is tossed 100 times. So the value of n is actually 100 and lands with head 62 times. So our x will be 62. Now we are substituting the values. So it will be 100 c of x, that is 62, p of our x, that is 62, into 1 minus p n minus x. So n is 100 minus 62, we will have 38. So we have found out the likelihood here. Now these all are multiplication. Now in MLE, next thing what you have to do is you have to find the log likelihood of this function. So let us find out the log likelihood. For the time being, I am representing log likelihood as LL, which is equal to log f of xi given theta. Okay. If we want to find out the log likelihood, we have to apply log on this side as well as this side. So I have applied the log on this side. Now I am going to apply the log on this side. It will be written as log 100c62. So whenever you apply log likelihood, the multiplication is going to be converted into addition. So we have to write plus here. So plus log p raised to 62 plus log 1 minus p raised to 38. So we have converted all the multiplication into addition. So therefore we are taking log likelihood to convert it into addition. Now in order to find out the maximum likelihood estimate, we have to differentiate DLL with respect to theta. Alright. So how it will come? First we apply logarithm, then we apply differentiation. So this term is actually a constant. It will become 0. Plus, if you take the logarithm of this, we will get 62 into 1 by p. Next term we will get 38 into minus 1 divided by 1 minus p. And we will equate it to 0. Now let us simplify it. It will become 62 by p plus minus 38 by 1 minus p, which is equal to 0. Now again you simplify it. You will get minus 62 plus 62p plus 38p, which is equal to 0. Alright. So how you can write it? 100p is equal to 62. So finally what will be the value of p? Therefore p is equal to 62 divided by 100, which is equal to 0.62. So we have found out the maximum likelihood for the probability of head, which is equal to 0.62. So finally let me write p of MLE is equal to 0.62. This is your answer. Understood, students, how to do this? The first thing what we have done is we have found out the distribution which is happening in your problem. Thereafter we have found out likelihood, then log likelihood, and in the another step what we have done is we have found out the differentiation of log likelihood and equated it to 0, and finally you will be getting some equations, and from this equation you are going to find out the value of MLE. Okay? Dear students, the video is becoming very large, so we will stop here and we will continue another problem in the next video. Thank you, students. Thank you for watching my video.